closer, breathe in the light, morning hum in the garden high. Every wing has a story to tell, every root knows how to heal. We listen, we learn, we gather and grow, where the bees and the wild things know.
Hello, bee enthusiasts. Welcome to the Attic Bee Podcast. I'm your host, Jody Schramm. Picture this. You're walking through your backyard on a warm spring afternoon when you hear it. A low, intense hum that seems to fill the air around you. You look up, and there, hanging from a tree branch, is what looks like a living, breathing mass the size of a basketball. Thousands of honeybees clinging to each other, forming a beard of insects that pulses and shifts like a single organism. Most people's first instinct? Run. But here's the thing. This is actually one of the most peaceful moments in a honeybee's life. Welcome to the world of honeybee swarms, where approximately 10,000 insects, weighing about 3 pounds total, the same weight as a human brain, by the way, come together to make one of nature's most sophisticated collective decisions. Today, we're diving into one of the most misunderstood and fascinating phenomena in the insect world. We'll explore why honeybees swarm, how they accomplish one of nature's most impressive feats of collective intelligence, and what we can learn from these tiny creatures about decision-making, democracy, and the power of working together. So why do honeybees swarm? Understanding this means understanding that swarming isn't actually a problem. It's a sign of success. In late spring or early summer, when flowers are blooming and nectar is flowing, a healthy honeybee colony is thriving. The worker bees are bringing in food, the queen is laying up to 2,000 eggs per day, and the hive is growing. But here's the catch. The hive itself isn't growing. That wooden box or hollow tree trunk has a fixed amount of space. So what happens when a successful family runs out of room? In human terms, we might build an addition or move to a bigger house. Well, honeybees do something similar, but far more dramatic. They reproduce at the colony level. This is called reproductive swarming, and it's how honeybee colonies multiply. Here's how it works. When the colony becomes crowded, the workers begin preparing for a split. They start raising new queens by feeding certain larvae a special diet of royal jelly. Meanwhile, the current queen, let's call her the matriarch, she begins to slim down. Worker bees actually put her on a diet, reducing her food intake so she can fly again. You see, during most of her life, a queen bee is so engorged with eggs that she's too heavy to fly. But for this journey, she needs to be flight ready. When the first of these new queens is about to emerge from her cell, that's the trigger. The old queen and about half the worker bees in the colony, sometimes 10,000 to 20,000 bees, gorge themselves on honey. They're essentially packing lunch for a journey of unknown length. Then, on a warm day, usually between 10 a.m. and 2 p.m., they pour out of the hive in a spectacular cloud of insects. This is the swarm. And here's the beautiful part. They're leaving the hive to the next generation. The new queen will emerge, mate, and continue the original colony. Meanwhile, the old queen and her followers are off to establish a new home. It's not an escape or an emergency. It's a planned succession. A carefully orchestrated split that allows one colony to become two. So now we have thousands of bees in the air with their queen. What happens next is equally fascinating. The swarm doesn't just fly off into the sunset. Instead, within a few minutes, they usually land on a nearby tree branch, fence post, or sometimes even a car bumper, forming that characteristic beard or cluster we talked about earlier. This is the temporary staging area, and it can last anywhere from a few hours to a few days. The bees form multiple layers, with the queen safely tucked somewhere in the middle. The outer bees cling to the inner bees, who cling to others, creating a living chain of insects. It's actually quite an engineering feat. They're using their own bodies as building material, creating a structure that protects the queen and maintains the right temperature for the group. And here's where things really get interesting. This 3-pound cluster of bees, remember, about the same weight as a human brain, is about to make one of the most important decisions of their lives: where to build their new home. And the process they use is so sophisticated that scientists have studied it to understand collective decision-making and even improve how humans make group choices. While the main swarm is hanging out in their temporary cluster, a special subset of workers gets to work. These are the scout bees, usually only about 3 to 5% of the swarm. So that could be 300 to 500 individuals out of our 10,000. These scouts have one job: find potential new homes. Scout bees fly out in all directions, searching for suitable cavities. They're looking for very specific criteria. The ideal home needs to be about 40 liters in volume, roughly the size of a standard filing cabinet. It needs a small entrance, preferably facing south or southeast, positioned high off the ground, and it needs to be dry and defensible. When a scout finds a potential site, she doesn't just come back and report it. She actually inspects it thoroughly, flying around the inside, measuring the volume by pacing out the interior dimensions. Scientists believe bees measure cavity volume by the amount of time it takes them to walk across the surfaces. It's like measuring a room by pacing it out, except these bees are doing it in 3 dimensions while crawling on the ceilings and walls. And here's where it gets amazing. If a scout likes what she finds, she returns to the swarm and performs a waggle dance on the surface of the cluster. Now, we've talked before about the honeybee waggle dance. It's one of the most famous examples of animal communication. The dance is a figure 8 pattern, and embedded in this dance is precise information. The angle of the dance relative to the sun tells the other bees which direction to fly. The duration of the waggling portion tells them how far away the site is. And the enthusiasm of the dance, how vigorously and how many times she repeats it, communicates the quality of the site. I just love this idea. Now, here's where the swarm's collective intelligence really shines. Multiple scouts are finding multiple sites and coming back to dance. So at any given time, there might be bees dancing for 5, 10, or even 20 different locations. It's like having 20 different real estate agents all pitching their favorite properties simultaneously. But the swarm can only choose one home. So how do they decide? This is where Professor Thomas Seeley of Cornell University has done groundbreaking research. Seeley and his colleagues discovered that honeybee swarms use a process that's remarkably similar to how neurons in the brain reach a decision. It's called a quorum system. Here's how it works. When a scout bee dances for a site, she might recruit other scouts to go check it out. If those scouts also like the site, they come back and dance for it too. Gradually, more and more bees are dancing for the best sites, while enthusiasm wanes for the mediocre ones. The scouts actually visit the sites being advertised by other dancers, independently verifying the quality. But here's the crucial part. A scout who's dancing for site A might go check out site B that another bee is advertising. If site B is better, she'll stop dancing for site A and start dancing for site B instead. The bees are constantly reassessing, updating their opinions based on new information. It's peer review in real time. The decision is made when enough scouts, a quorum, usually about 15 to 20 bees, are present at a single site at the same time. That's the threshold. When scouts visiting a particular cavity notice that many of their sisters are also there, it triggers a response. This is the one. The scouts return to the swarm and begin producing a special signal called piping. This high-pitched sound, combined with a behavior called the buzz run, where bees run across the cluster, vibrating their flight muscles, warms up the swarm, and signals it's time to move. Then, as if on cue, the entire swarm takes flight. Thousands of bees launch into the air, forming a cloud that streams toward their new home, guided by the scouts who have been there before. I want to pause for a moment on that comparison I made earlier. A honeybee swarm weighs about 3 pounds, the same as an adult human brain. There is something incredibly poetic about that coincidence, but it's also instructive. Your brain contains roughly 86 billion neurons. Each neuron is a simple cell that can either fire or not fire, on or off. But connected together, exchanging information through electrical and chemical signals, these simple units create consciousness, memory, emotion, and reason. Your neurons individually don't know anything, but collectively, they create your mind. A honeybee swarm contains about 10,000 individuals, give or take. Each bee has a tiny brain with about 1 million neurons. Simple compared to ours, but complex enough to learn, navigate, and make decisions. Individually, each bee has limited information and limited capacity, but connected together through their dances, their pheromones, and their physical interactions, they create something that looks an awful lot like collective intelligence. When scientists study swarm decision-making, they find it remarkably effective. Honeybee swarms almost always choose the best site available. Not just a good enough site, but genuinely the best option from among all those scouted. They can weigh multiple factors: cavity volume, entrance size, height from the ground, structural integrity, distance from the current location. They can even factor in the urgency of the situation. If weather is threatening, they'll speed up their decision process and possibly accept a slightly less ideal site rather than risk getting caught in the rain. And they do all of this without a leader. Remember, the queen really doesn't rule the hive. She's there as the egg layer. There's no CEO bee making the final call. The queen doesn't vote or decide. She just goes where the swarm goes. The decision emerges from the bottom up, from the interactions of hundreds of independent agents, each following simple rules, but creating complex, effective outcomes. So what can we learn from honeybees, especially in this context? Researchers have actually applied insights from swarm intelligence to human decision-making. First, there's the power of diverse information gathering. The bees don't just send scouts in one direction or have a single bee make the choice. They distribute the search, ensuring a wide sample of possibilities. Second, there's independent verification. Bees don't trust one scout's opinion. They go check for themselves, which prevents the spread of bad information. Third, there's a balance between commitment and flexibility. Scouts are passionate advocates for good sites. That enthusiastic dancing really does matter. But they're also willing to change their minds when presented with better evidence. Fourth, there's the quorum threshold. The bees don't require 100% agreement or even majority rule. They just need enough scouts to verify that a site is good. This prevents decision paralysis while still ensuring quality. And finally, there's the distribution of cognitive labor. Not every bee needs to visit every site or understand every detail. Specialization and information sharing allow the collective to process far more data than any individual could. Companies and organizations have started using these principles. Some businesses now structure decision-making committees to mimic swarm intelligence, with independent teams evaluating options and only converging after each one has done their own analysis. Computer scientists have designed algorithms based on bee behavior to optimize everything from internet routing to robot coordination. But let's come back to our swarm. They've made their decision, they've taken flight, and now they're approaching their new home. Maybe a hollow in an old oak tree. Maybe a gap in someone's attic. Maybe a cavity in a rock wall. The scouts who know the location fly in characteristic, fast, direct patterns, essentially saying, "This way, this way." The swarm follows, and within minutes, bees begin pouring into their new home. The transformation from homeless cluster to housed colony happens remarkably fast. Within hours, workers are already building fresh comb, laying down the hexagonal wax cells that will store honey and house the next generation. The queen, who has been on a diet and essentially on vacation from egg laying, is fed by the workers and soon begins laying again. Guards take up positions at the entrance. Foragers begin mapping the neighborhood, locating flowers, water sources, and landmarks. That 3 pounds of bees has successfully completed one of nature's most remarkable journeys. They've split from their parent colony, protected their queen through a vulnerable transition, collectively searched an area of several square miles, evaluated dozens of potential homes against multiple criteria, reached a democratic decision without a vote, and established a new colony, all in the span of just a few days. Honeybee swarms remind us that intelligence and wisdom don't always look the way we expect them to. There's no boardroom in the hive, no committees filing reports, no PowerPoint presentations. Just thousands of individuals, each doing their part, each contributing their piece of information, and together creating something far smarter than any single bee could achieve. The next time you see a swarm, and remember, they're not aggressive during this time because they're focused on their mission, not defending territory, take a moment to appreciate what you're witnessing. It's miraculous. That cluster of bees isn't just a mass of insects. It's a distributed brain weighing about 3 pounds in the process of making one of the most important decisions of its collective life. And maybe there's something we can learn from these tiny creatures about how to make better decisions ourselves. Gather diverse information, verify independently, stay flexible, build consensus, and trust in the wisdom that emerges when individuals work together toward a common goal. Thanks for listening. Until next time, keep looking up. You never know when you might spot 3 pounds of pure collective genius hanging from a tree branch. And if you enjoyed this episode, please subscribe, share it with somebody who might enjoy it, and tune in next week for another episode of the Attic Bee Podcast.
As the day settles back into green, let the quiet stay with you. Tend the small things, rest and remember. The hive is humming.